Right, hello. I'm not going to do a sales pitch. You'll be glad about that. I've got enough people that we employ that wear ties that can do that for you. Some of them wear jackets indoors when it's warm as well. So my name is Joe Baguley, and I have the best job in the world. Because I get to work with some bloody clever people, is the best way to put that, really. So, to give you an idea of the kind of people that I get to work with in leading innovation at VMware, and there's two of us that are part of the CTO team. It's my colleague in the US. My colleague in the US was the guy that invented containers on Solaris, or virtualization, those of you who know that is. He also designed the infrastructure for eBay. Another guy that works with me is the guy that invented, or let's just say wrote the kernel for Windows NT, and was the guy that Steve Ballmer threw a chair at when he said he was going to leave and go and work for another company. I've got another guy who designed clustering on Wolfpack, on NT. Myself, unfortunately, I had various things to do with writing OpenView and Active Directory, for which I'm eternally sorry to all of you for all of that. Are you okay without the mic? Is that, I'm going to move in and out. I've got quite a loud voice. I was an officer in the army for long enough. So a little bit about me. We need to do the history and the technical credibility piece first. So this is me. I'm the one in the middle, the little boy, aged 3. I was blonde, yes, it's true. My mum did not dye my hair, though it was the 70s, so anything could have gone, to be honest, really, judging by the trousers and the huge belt buckle. I'm wearing an IBM t-shirt because my father worked for IBM for 34 years. He was one of those lucky final salary pension people that now sits there and gets a pay rise every year, which a lot of people who work for IBM still don't. And the interesting thing there is that we're at a family fun day, and we're not using a rope for tug of war. That's the interface cable from the System 36 mainframe, because they didn't have a rope and my dad stole it from the demo suite. And apparently he put it back and it still works. It's probably in a bank somewhere in the city right now. But the interesting thing is he was the product manager for VM at some point during his career, and so I'm kind of a second generation virtualization guy, I suppose, if you want to look at it that way. He also was the guy that started and launched AIX, which officially died 2 weeks ago, which is also quite sad. I went around his house for a mini wake for that one. The point being that our industry started in mainframes. It's really where we first started to get computers because computers were interesting to use for the business. And at that point, that's where the term user started. Because you were someone who was allowed to use the precious computer that was being run by the people who were very clever who ran the computer. Okay. And that's what's been turned on its head in recent years. But the priority there was really around control. Then we moved into an era that a large percentage of us, I think, here have grown up in, which is the client-server era, which is where we moved to millions of users using thousands of apps as an industry. And there it was about building competency silos. You built the networking team, the storage team, the compute team, the database team, who woe betide would never talk to the application team because they wear different coloured shirts and so on and so forth. The security team, who no one talks to because they're quite nasty people, and so on and so forth. Usually failed bullies in my experience. And then we've now moved into a rather interesting phase. We're now in the stupidly big era, I think is the best way to describe it. Our marketing people have called it mobile cloud, but to be fair, I think that's a fairly good recommendation or a representation of what we're doing here. We're looking at an environment with billions of users, with millions of apps. And now there's a really interesting tipping point in our industry. Because we've all grown up, well, some of us are a lot younger than I am, but most of us have grown up in the world where enterprise class was it, right? Your product's got to be enterprise class. It's what it's got. Is it enterprise class? Good, because that's what we need. Well, now the shocking thing is consumer grade is better than enterprise grade. Or consumer class is better than enterprise grade. And you look at me confused, some of you going, what's that all about? Well, that's the problem, and that's what's come up with bring your own device. Because guys are now walking into your companies and going, I want to access your systems on this thing. And you go, that's a bit funny, that's an old iPhone 4. No. You go, and they go, well, why can't I? Now, 5 years ago, you could have gone, just because it's technical, it's really hard. Haha. And they would have gone, okay, fine, I agree. Now, You go, no, we can't do that because your device isn't secure and it's not scalable, you know, blah, 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 lots of other reasons for saying no, because you work in IT, therefore you are the department of no, that's your job. And now they have a response. Because they go, well, hang on a second, my bank can deliver an application to my iPhone that allows me to access my money. So why can't you deliver an app that allows me to access your pathetic little CRM system? And now that's where the problem comes. Because consumer grade wins. And that's what IT needs to think about as we go forward, is how do we turn ourselves into being the same kind of people that deliver the same level of service that our consumers are now used to. And the point is that these consumers are creating data at a rate that has never, ever been seen before. And it's quite stunning when you get into the figures. Now, I'm all about the future stuff. I usually disagree with analysts because I believe they have a job just making stuff up and getting paid for it, which I think is my job. And but they make up numbers, and they say, by the year 2015 we'll have this much data and blah, blah, blah. I prefer to look backwards. So let's look backwards together at the growth of data. So first of all, I need to introduce you to some prefixes that you're going to have to know going forward in the future, because it's going to become a reality. We know what a kilobyte, a megabyte, a gigabyte, a terabyte is. Most people know that. A large portion of people know what a petabyte is, which is 1,000 terabytes. That's quite a lot of storage. It's really quite a lot of storage. And then you have an exabyte, which is 1,000 petabytes, which is 1,000,000 terabytes, or 1 billion gigabytes, an exabyte. That's a huge amount of data. It took EMC, and I'm only using them because they put this out publicly, not because I'm interested in them. It took EMC 20 years until 2005 to sell a total of an exabyte of storage. 20 years to sell a total of an exabyte of storage. 20 years to sell 1 billion gigabytes of spinning Rust. Okay? That's what it was back then. In 2010, they sold an exabyte in a year. In 2011 Q3, they sold an exabyte in a quarter. In June this year, they sold an exabyte in a month. And at some point, we're having bets internally amongst our management team as to which week it is next year that they sell an exabyte in a week. They have one customer took an order, in one order, of 85 petabytes. So this stuff is growing at an unbelievable rate. Right now, people are not knocking down data centers. They're building bigger and faster than ever before. At the same time, we've got people out there taking selfie videos and filling up our storage faster than you'd ever want. Okay? Unfortunately, it's smartphones that have really caused the big explosion of data content. It's actually the devices out there capturing information and data in time, and then when we start bringing machines online, it's just going to get worse. We spun out a company earlier this year called Pivotal, which is in the sort of big data application space, and they're the leaders in agile development and big data platforms. And they also took some of the stuff from EMC as well, such as Greenplum. And they ended up, we spun them out, and within a month, GE had invested to buy 10% of this company, Pivotal, for $100 million. So they valued this startup at $1 billion within a month of it being launched. Why on earth would GE invest in an agile development big data company? It's because GE make big machines. And big machines are generating data all the time. I don't know if you realise it, but GE provide engines for aircraft, as do Rolls-Royce. And when those engines are in flight, they're real-time now, feeding back streams of data as to their performance and the characteristics of that engine, such that when it lands in its destination, they know exactly what part needs servicing or how much servicing needs to be done, which helps save them money. At the same time, because customers never buy an engine, they buy power in hourly units, by the way, which just happens to be delivered by an engine they stick on the plane. It helps them cut their costs and manage it to a limit. They also do that for power stations as well, with generators. And so data is going to become massively important. So we have a problem with storage. But if we think back, I did a computer science degree, well, actually, let's frame that properly. I started a computer science degree. I didn't finish a computer science degree. I changed to theoretical physics because my girlfriend did that and the lectures were in the afternoon. True story. And but when you do computer science as a pure subject, what happens is initially you start working in a pseudo world using a thing called pseudocode. Some of you may remember using pseudocode, some of you may use it today, or predicate logic formula or other stuff like that. And what happens is you work in a world where you don't care about storage. You don't care about processor power, you don't care about networking, you just write something, right? Okay, that's not your concern. Because storage is unlimited and fast and right next to the processor. And the processor has unlimited capabilities and there's no such thing as a network. Everything's connected to everything else. So you do that, and then you try and take it to the real world, at which point you have to take compromises. And that's what we did. We took compromises. The first compromise was punch cards. We couldn't actually have unlimited storage right next to a processor. We had to store it in paper and read it into a machine. And that storage, over the years, is coming back to where it should be, which is unlimited, fast storage next to the processor. Now at the moment, we've got to the stage where the storage is on SSDs, which is solid-state drives, being plugged into PCIe cards, which is the sockets on the motherboard that are usually used for I/O, which is phenomenally fast when you talk to customers. They think that's brilliant. Okay. Well, there's companies now, like Diablo Technologies and others, that are taking SSD cards and plugging them directly into DIMM sockets. That's the place you put RAM. They're putting storage in there because it's cost-effective now and fast enough to do that. And typically, there's more DIMM sockets than PCIe sockets on a motherboard, so it's better. Well, I can tell you from conversations we have with Intel that in about 4 or 5 years, plugging SSDs into DIMM sockets is going to look proper rubbish, right, compared to what's happening. So what's happening is the storage is getting back to where it should be, next to the processor. Not in some large storage array somewhere else, but right next to the processor. And the same is happening with the network. And I'll get into that in a minute. But we have another limiting factor, which brings me on to the second part of my misspent youth at Imperial College, is the speed of light. Now, Grace Hopper, who was very famous in the world of computing, those who know computing history, actually used to illustrate this quite well with different lengths of copper wire. But I don't have the luxury of carrying copper wire around in my laptop bag. It doesn't get through security very well. So we have a problem in IT. And the problem is this. Light's not very fast. In 1 nanosecond, light, and 1 nanosecond is not a very long time, right? But it's, that's 1 gigahertz. 1 nanosecond, 1 gigahertz. Light travels 30 centimeters. You'd think it would be like a mile or something, wouldn't you, right? No, it's 30 centimeters in 1 nanosecond. So if I've got a processor here, operating at 1 gigahertz, and I want it to talk to a piece of storage here at 1 gigahertz, the farthest I can put those apart if I'm using light in a vacuum is 30 centimeters, but actually when I start to come down to copper, it's more like 15 centimeters. Okay, Joe, what's the problem? Fine. And when I get to 10 gigahertz, it's 1.5 centimeters. When I get to 100 gigahertz, it's 0.15 centimeters, and so on and so on and so forth. So we can't keep building, though we've hit today in semiconductor lithographics and others a limit in terms of heat and cross-channel interference due to current and stuff. We're actually hitting a problem with physics and we can't move data around that fast. So we're not going to be able to build bigger and bigger and bigger processors. Now, a lot of very clever people, including IBM, realized this a very long time ago, and that's why you started to get symmetric multiprocessing. And that's why you start to get parallel processing. And it's why now you're seeing a trend in our industry for scale out, not scale up. So the overall trend is that the storage and the networking is getting closer to the processor as discrete nodes. And what we're doing is we're getting thousands of those nodes together to form a new concept of what a computer is. And so cloud is really sort of 2 trends. If you look at what's going on in the industry, we can define it in a million ways, and I have, trust me, hours of fun doing that over the last God knows how many years. But in essence, cloud is 2 very simple trends. You've got monolithic applications, your classic 3-tier database application, whatever, gone, because that's becoming distributed services. And from a physical perspective, you're looking from loosely connected discrete resources to a virtualized fabric of resources. And to do that, we're going through a cycle, which IT, as my father quite rightly tells me, has been going on for a very long time, of abstracting, pooling, and automating resources. Now, what do I mean by abstract, pool, and automate? Well, let me explain it to you in the context of the real world. In the real world, containerization transformed global commerce. Before the 1950s, you had specific types of boat and specific types of train truck and everything for particular types of cargo. The banana boat, etc., etc. And then someone had a really good idea. Why don't we just invent a standard box? And then we put everything in those boxes, and then we just invent things that carry those boxes around. Then we can achieve scale and efficiency. And that's exactly what happened. Just true to form of computing, they did argue over standards for about 7 years. But we ended up with containers, and the shipping container absolutely transformed the world of commerce. It now means I can buy stupidly cheap things from China for next to nothing, and the shipping's nearly free because of the price of the containerization and the shipping has changed. And that's why you now get these incredibly huge boats, bigger than ever before, carrying thousands and thousands of containers. It's exactly what virtualization was. What virtualization has done, whether it's us or anyone else, has taken the workloads, those things that particularly before used to be tied to a particular piece of hardware, put them in a shipping container that now means they can be moved to anywhere you want to run on any piece of hardware. So that containerization was the first step. Now when we did it, people didn't do it for that benefit. People did virtualization for other reasons. They wanted to consolidate servers, save power, all those kind of things, which are all good reasons. But what you don't realize is, sneakily, we've made all of your workloads mobile and portable. The next thing that transformed commerce globally was automation. Now, a lot of people will tell me that they do automation in IT. Oh yes, I've automated that. No, you haven't. You've written a Perl script. It's not really automating something. You've just written a script. That's lazy. That's not automating. You're still making decisions yourself, most of the case. And this is because of the way that there's two different types of workload in today's computing world. The first type of workload looks like this. Okay? That's a chinchilla Persian kitten. Belongs to one of my kids. It's sat on my laptop because my laptop is made of warm. And this is how most people view their servers in IT. They know the names of their servers. They pet their servers. They maybe even take pictures of their servers and put them on fridges. If the server's feeling particularly sick, they spend an awful lot of money taking it to someone to get it fixed. That's how people manage servers today. They're focused on the fact that they have to manage the server, not the service. So we all manage these kittens. We will manage these servers, and I bet you if I go and walk and ask some of the admins in your organizations or people that you know, they will be able to tell you the names of their servers, the IP addresses of their servers. They're more likely named after characters from Lord of the Rings or something like that, because mine certainly were. Okay? And I can still tell you the IP addresses of the machines I used to manage in the 1990s, because I loved them so much. Okay? Now I can tell you from personal experience there's a limit to how many cats you can manage, unless you're the mad cat woman of Cork, right? There's a limit to how many cats you can manage. Just like there's a limit to how many cats or servers a person can manage in an organisation. Which leads me on to Netflix, which is rather strange, but bear with me. From cats to Netflix. I think you can watch cat movies on Netflix, so there's kind of a link. Okay? Now Netflix are famous. They're famous because they're a cloud application. They do things in the cloud. They run on Amazon. It's all fantastic and scalable. They're famous because they're the only ones that really do that, but they use this new style of management for these new style of applications. Because I can tell you right now, Netflix do not have kittens. They have something completely different. They manage a chicken farm. Okay, so bear with me on this one. All right? They don't have 100 servers. They have hundreds of thousands of servers. Now, when you're managing hundreds of thousands of servers, I can tell you right now, you don't know all their names. They probably don't even have names, they just have numbers. I can also tell you that if one of them gets a bit sick, you don't take it to the vet. Because chickens are quite cheap, you can get rid of that one and get another one. Okay? What they care about is the output. They care about the eggs. And they put automation in place to manage them. I've got a friend, this is no word of a lie, it's a guy who did the theoretical physics degree with me, and now runs a chicken farm. There you are. That's what happens with theoretical physicists. And they either go on television and point up in the sky a lot, or they go and run chicken farms. And he now has 14,500 chickens, which he manages in an automated fashion, which is really cool from a geek perspective. He has a tool, in fact it's a whole thing, that analyses the output of the chickens. And I'm not talking about the eggs, okay? And it then assesses their diet and feeding based on what's coming out of them. So automated management of chickens. At the same time, he cares obviously if 10% of the chickens aren't performing. Now, here's the interesting thing and how it comes back to Netflix. Netflix run a process called the Chaos Monkey, which is available as an open source tool if you like. They have a whole range of monkeys. Adrian calls them his simian army. But the Chaos Monkey is quite a good one. The Chaos Monkey runs in their live production system and randomly breaks stuff. That's what it's for. It runs in their 100,000 chicken farm and goes around randomly killing chickens. And if the egg production stops, then there's a problem. So his developers are developing for the fact that the Chaos Monkey is there, doing way worse to his application than anything the real world's going to do to it. It's happening all the time. At the same time, the guys that develop it also support it. So this is the whole DevOps thing. So as you go forward, you can see how we need to think about automation in IT very differently. We need to stop thinking about Git and type management and pet management and change our processes to grand scale farming. Because if we're going to build these mass scale out environments, you can't do it using the classic Perl scripts. You need to take away the classic siloed management and start to work towards this sort of cloud infrastructure management technique. And start thinking of things as amorphous blobs. So something else that needs to happen in IT, that has happened in the real world, is standardization. Now I'm not talking about standards like the RJ45 connector and USB and TCP/IP because they are interesting standards. I'm talking about standardizations as part of the automation process. The way that most IT works at the moment is they build individual Formula 1 cars for every single request. You come in with a bespoke request and they'll give you a very expensive bespoke answer. We'll build you a specialist system, we'll build you specialist hardware, we'll customize the application, we'll make it all perfect for you. But two things there, Formula 1 cars are fragile and they're very expensive. Surely it's more efficient to start building, I don't know, Toyota Corollas, because that's going to be much more scalable and supportable. And so you need to start thinking a bit more like coffee shops, because I can't walk into the local coffee shop and ask for a medium and a bit. It's just not what you do, right? You can't go, well, I don't really want a large, I don't want that much, but I want a bit more than a medium. So can you do me a medium and a bit in a large cup? Right, try that next time. See what they say. However, you still have massive choice in a coffee shop, because they have a bunch of standard components, syrups, sugar, milk, God knows what else. You can come out with coffee orders that are far too long in terms of the number. By the way, if you've got a coffee order that's longer than 5 words, you need to seek specialist help. But you can come up with these amazing, great big long concoctions for what's essentially coffee. And that's how you need to think about how you're going to operate IT. It's the same as, for example, Land Rover operates. There's no two Range Rovers that roll off the Land Rover production line that are the same. But they're built from a standard parts bin on a standard production line. And they're supported by a franchise dealership using standard manuals. And so if we go forward with standardized components of storage, networking, and compute, and then use those standardized components to build myriad combinations, we achieve a level of supportability that we've not achieved before. And this is how large-scale cloud operators think. And so therefore you can, from multiple different components, build lots of different pieces. And so we call, and we invented the term, in fact myself and 2 other people at VMware invented it, and we weren't drunk at the time, honest. The software-defined data center. And what we mean by the software-defined data center is really everything done in software. So how does that come together? And this isn't a sales pitch, by the way. I just want to explain what's going on in our industry, because everyone's doing this. At the moment, virtualization was fantastic, because we went from this thing where before you had to spend $10,000 and take 10 weeks to get a physical server up and running in your environment. So we said, virtualization, it's the future. And everyone deployed virtualization, and now you can get a server started in 2 minutes, and it costs a fraction of the price. Awesome, all my problems are solved. But no. Because you stand that up, and then you find that standing up a VM on its own is not really enough, because to go with that, you need storage, networking, security, identity management, availability, so all that kind of monitoring stuff needs to be done. And that tends to add an awful lot more time to the process, because a lot of those are still manual, disjointed silos. So as the storage and the networking, and in turn with both of those, the security, get closer to these processes, in these scale-out nodes over the next few years, what we need to do is work on getting all of those pieces together into one combined software lump, I suppose, that then means when you then want to provision a VM, those services beneath are automatically configured at the same time. So the concept to understand about a software-defined data center is actually very simple. In a software-defined data center, all of the infrastructure services are delivered as software. And the control of that data center is entirely driven by software. At which point you think to yourselves, but what about the hardware people? Good question. Okay, very good question. You've probably worked out for yourself, but it's not good. It was pointed out to me at the end of last year, and it's still roughly true, in fact it's more true in some cases, that everyone went, oh, VMware, you're the little virtualization company, aren't you? Yeah, that's fine. And we have some analysts who work with us. And they pointed out something that we've never really looked at, because we're not really this, big-headed about it. But we went and had a look, and our market capitalization, our valuation on the stock exchange, is $40 billion. About the same as HP. Nearly twice as much as Dell. And we're just the virtualization guys. But we're building software, because the future is software. And the famous computer scientist Alan Kay once said that if you're really serious about software, you should be building your own hardware. Well, we're kind of getting there as an industry, but that's what we're doing. The future is the intelligence moves into software and out of the hardware. We've already seen this in computing. When we first virtualized the processor, everyone said, well, Intel's going to be upset. They're going to sell less processors. Well, they weren't really. They actually built specific processors for us, worked very closely with us, and now their CTO is our CEO. So, not done that bad. Very interesting guy to talk to have your boss being the CEO, who usually is a bit not very technical, is the guy who architected the 286 and 386. There's not much he doesn't know about technology. At the same time, they then said, but then the tin vendors, they're going to be really upset with you because they're going to sell less servers. No, they built specific servers architected around virtualization, and the market grew. And as I said before, no one's knocking down data centers, they're just building them differently to before. And so as we go forward and start taking this out, we're going to break down these silos. So let me tell you about network virtualization, what network virtualization is, because you'll hear a lot about SDN, software-defined networking. A lot of it is said by people who think from a networking perspective. I'm going to tell you what software-defined networking is from a compute perspective, which is actually the proper way to think about it. And of course I'm going to say that, but bear with me. So this is pretty much what you look like in a virtualized environment today. You have a hypervisor on each side, on some hosts, and in the middle you've got some physical switches. Those are the boxes that actually transmit data from one place to the next. And then on top of the hypervisor I run a virtual machine. To get data from one to the other, it goes through the hypervisor, across there, through the switches, through the hypervisor to the other virtual machine. If you didn't catch that, I'll do it again. It comes out there, through the hypervisor, through the switches, maybe slightly different route, through the hypervisor up to the virtual machine again. And at that point, someone went, well, hang on a second, we spend a lot of money on intelligence in that middle piece. We spend a lot of money in making sure those switches are all very well configured, etc., etc. But they also spotted, and this was actually a guy doing his PhD at Stanford, who then founded a small company that we bought for $1.26 billion last year. He's doing quite well now. But hang on a second, why don't we take that intelligence and put it in the hypervisor? Because everything's going through the hypervisor anyway. Why don't we get rid of the bottleneck in the middle of these network devices? And why don't we move all the intelligence to the hypervisor, so every time we add a new piece of hardware, we get more storage and more networking, right? That's what happened. So instead, what we did was we put the switching technology and knowledge into the hypervisor. And now, the intelligence is done up there. Now at this moment, you look and say, well, the blue thing still went the same way, Joe. Big deal. Bear with me, okay? Because it still happens to the next one as well. But it means that those ones in the middle are now becoming commoditized and not so interesting and exciting anymore. Which is good if you're a software company, not so good if you're a hardware networking company. Now, it gets interesting when we get to routing. Now, routing is a bit more interesting because it says this packet needs to go here because of this rule, or this packet can't go there, or this packet goes that way. Now, at the moment, if I've got a VM and I want to talk to another thing, it comes out of there, it goes to the router, and then goes back. Oh, yeah. Notice the VMs are both on the same machine, yet I had to go out to the network to find out that I had to go all the way back to where I started to the VM that's sitting next to me. Can you see where the thinking went now? If I move the routing into the hypervisor, then surely I never need to leave. How clever is that? And in fact, when we put this in tests in customers, and we've got customers such as Citi, GE, eBay, and others using this today, they've seen that 70% of the network traffic in the middle disappeared. Because a lot of it was stuff coming out to go back to the same place. And in fact, we run some optimization software in our virtualized environments that moves the virtual machines around. And you get this, we have a thing called vMotion that allows you to move a virtual machine whilst it's running from one computer to another computer. It's called vMotion. That's equivalent to me getting my laptop and running a video on it and dragging and dropping the video over to your laptop, and it's still running. But we do that with live production workflows like SAP. Now, we move them around based on what they're using. So maybe you find this one's being a bit busy and noisy, so we'll move this one off somewhere else to give that one more space to breathe. We'll also now think about the future where these workloads are moving around based on which other machines they talk to. And so then we move firewalls in there as well. In fact, we move all the layer 3 to 7 services into the hypervisor. So the firewall moves in. So now instead of going all the way out to the firewall to find out the packet needs to be dropped, I'm dropping it at the hypervisor. And load balancers, in fact, any layer 3 to 7 service you can think of ends up in the hypervisor. And so what this means is that that bit in the middle now just needs to move stuff really fast for me, please. I don't need any intelligence here. I just need you to literally connect my servers together fast. And so that's why you're already seeing the rise of commoditized networking vendors such as Cumulus Networks and others popping up with commoditized boxes with an open source operating system on them that provide and work as switches. It might interest you to know that even before we acquired Nicira, we were the 3rd largest networking company in the world in terms of ports shipped, except all our ports were virtual and not real. But we were the 3rd largest in terms of number of ports shipped. So again, by that, it means that instead of minutes to configure the VM and then days to configure the switch, router, firewall, and load balancer, interesting fact on firewalls, no one ever deletes rules, they just add them. Okay. We now change that from days down to, obviously, minutes to go with it. And the same is when you do the same with storage. What's happening in the industry now, again, we're not the only ones doing this, there's others as well, I've noticed that this storage is getting closer to the processor. So if this storage is getting close to the processor, we've now got a problem that our storage is now all decentralized again. How do we manage that? Also, how do we take advantage of that? And that's where we decided, along with some others, that we should gather all that into one virtual construct called virtual SAN, and we'll make all the disks that are local to servers look like one big disk that's centralized, and we'll put all the intelligence in there about failover, redundancy, etc., etc. So again, we bring the storage intelligence to be part of the compute layer. So now, if you think about it, we take these silos of storage, networking, compute, security, and we gather them together into abstracted pools. And they're now flexible, and they can now move very easily from one piece of hardware to another, because the storage and the networking go with that virtual machine as it moves around. So really, I'll click through this one here. You can now, from these components, these standardized components in the software-defined data center, the virtual data center that we talked about earlier, very quickly build individual configurations that look like completely different data centers. And so really, I'd like to think that what we're working on as an industry is automating all the rest of the stuff and virtualizing all the rest of the stuff to make sure that we're now down to a truly virtual data center. Because once it's virtualized, the nice thing is it's then portable, and you can then move your workloads out to a public data center, or back again to the private data center. Back again, or what? Back again? Everyone just goes to the public cloud and comes back, doesn't they? Well, no. It's not what's happening in the real world. Zynga. Some of you have heard of Zynga. They make games like Candy Crush and Farmville and all those other annoying notifications you get on Facebook from clueless friends who really shouldn't be allowed to use computers. And they are famous because they use the public cloud, but they use the public cloud in a special way. They use Amazon. And what they do is they spin up on Amazon a new game. They then see how that game gets on. And once the game has settled down to a fairly constant rate, they then bring it back on site. Because it's actually cheaper to run a consistent workload on site than in a pay-per-hour public cloud. It's been proven time and time again. If you've got an elastic variable thing, fine, put it in a pay-per-hour. If it's going to be fairly consistent, continual, bring it back in-house because a lot of people are finding it cheaper. Or maybe somewhere else, public cloud, that's providing a different pricing model. What people want is this ability to run any application, any place with no changes. And so by virtualizing all of those components, storage, compute, and networking, they all go with the workload wherever it goes. Its IP address doesn't even change. And so really, if you're sort of looking forward as to what's happening in the data center and what's happening in our industry, you're looking at two types of application, as I said before. You're looking at the traditional applications here, your Oracles, SAPs, your three-tier applications, what we all know and love, your CATs, and then they're going to still grow by about 70% by 2016. And then over here, you're looking at your future cloud applications, your Python, Ruby, Rails, Grails, stuff written in Spring, Hadoop, and other workloads, which there's a brilliant made-up marketing number here of 700%. It's just too big to have been based in any fact, but it's interesting nonetheless, right? It's impressive. It's conveniently 10 times that. Wonder how that happened.
Yeah, right.
But I think the argument here is that the growth of these workloads is going to far outpace the growth of the classic CATs, so the chicken-type workloads are going to outgrow it. But the important thing is making sure that what we build as an industry is a solid foundation here that sits across all of our infrastructure and provides a place for both of those to be. Because we had talk earlier on of a tier 2 data center. A lot of people know what the tiers of data centers are, tier 4 being the top. People make up higher ones, but trust me, the tier 4 is the top official one. Now imagine, as a final thing now, you go back to your RAID arrays. Right? Remember, and those who know RAID, which is where I get 4 or 5 disks, and I make them look like one big disk. And then I can lose one of those disks at any time. And the thing above doesn't notice, right? The thing using the service doesn't notice, carries on. Now imagine if I swapped where it said RAID for software-defined data center, and where it was disks, it said data centers. So now I can lose a data center without the workloads on top, be them old or new, noticing. Because all of the intelligence is moved into software. It's more easily portable, replicable, and everything else. And that's what the industry is building. So we're looking at a hardware that's going to be filling data centers with commoditized, possibly converged infrastructure, converged being storage and compute in one node, at the same time scaling out massively across multiple locations, and turning maybe each of those locations into a failure node in its own right. I had a friend who worked for Google in reliability engineering, and his job for 6 months was to fly randomly around the world to Google data centers, wait till the guy who ran the data center went on a break, and then turn the whole data center off. And he saw that if the bloke then finished his cigarette, it was all right. And that's what they did, because that's what the infrastructure they built, because they realized that's the way we need to build systems going forward. So we need to build systems that are reliant, built in that way. Now the interesting thing is here, you'll hear talk of PaaS, Platform as a Service, which really sits up here in this space, and that's where you hear things like Cloud Foundry, Google App Engine, Heroku, and others. So if you want to think of the future data center as one big computer stretched across multiple data centers, then what we classically called hardware is still hardware, but it's all of those servers and disks. Then what we classically called BIOS, the basic input-output system, the firmware that sat there between the operating system and the hardware and made it all seamless. That's infrastructure as a service, or the software-defined data center. It's the BIOS of the future computer. On top of that is the operating system of the future. And the operating system of the future is PaaS, things like Cloud Foundry. Because in the future, people will not turn up to you and say, I've written a really cool application, and you go, what does it run on? And they go, Solaris, AIX, HPUX, Windows, 5 different types of database, blah, blah, blah. They'll turn up to you and they'll go, it runs on Cloud Foundry. Because things like the Cloud Foundry, PaaS, and others will be the operating system of the future. And that's what companies like Pivotal are building. And obviously the applications will still be applications. It means those classic operating systems that we know, that run over here in the kitten world, will disappear. Because these things run very small appliance nodes running just enough Linux. Because that's all you need. Because it's the application handling above that's the interesting piece. So really what we're looking at going forward is building an environment called the software-defined data center, which is somewhere where both your kittens and your chickens can live together in perfect harmony. Okay? And so when you're going out thinking about your future strategy, think about the fact that today you've got kittens, and they're not going anywhere fast, they're going to stay around. And in the future, people are going to turn up and want to build chicken farms as well. And you need to find somewhere that will run kittens and chickens together across multiple commoditized hardware, where the value starts to be in that software layer. And with that, I'm done. So thank you very much.
So now we've got about 10 minutes, so if there's any questions, please feel free, harder the better.
And he's going to answer.
Does all that presuppose wonderfully fast networking? Go to URL and then you're screwed.
True. So the one issue we have.
Yeah, there's just so you
I'll
know,
just put the mic on.
the microphone's approved as well to ask the question. You can just press the button and ask the question. So if you want to give your name as well, that'd be good so we get to know each other.
So to repeat the question was that all relies on very fast networking, which is true. And so within a data center, that's not technically an issue because we've got 10 gig E, 40 gig E, but between data centers is where it becomes an issue. And so we're seeing some interesting advanced technologies in metro clustering that we're looking at the moment for doing that over short distances. But the long distances is where the real research is going on right now. At the same time, there's 3 worlds in IT. Okay, there is Silicon Valley, which is in a world of its own in every sense of the word. Okay, and they think they know what's going on in the real world, but it's not true. Okay, then you have sort of Western America and a bit of East Coast, which is the next sort of the second world of IT. And then you have the rest of the world of IT, which is all of us and everyone else who are actually still doing it for real. And to give you an example, people in Silicon Valley are the guys that think that they can roll out things that just work on Wi-Fi because everywhere's got free Wi-Fi, right? There's free Wi-Fi everywhere, in every Starbucks. Yeah, but not in Cork it isn't, and not in London it isn't, not everywhere else. So I agree with you entirely. And so, in fact, the one thing that's holding us back as an industry is networking. Everything else has outpaced networking by multiples. And in fact, some of the innovation you're going to see, and certainly some of the innovation we're talking about our partners with, is in networking. Not 10 gig E, 40 gig E, but 100 gig E, and so on and so forth. And there's some really weird research that's going on about interleaved overlapping light paths that can give us terabits per second, etc., etc. So some of that's happening too, because this stuff has to be pushed around from one place to another. And I always think it's funny when people talk about failing workloads from one data center to another in a second. And I'm like, how do you move 4.5 terabytes in a second? It's not possible. So there's a lot of things to be done. And we have to work intelligently around that for now.
Thank you.
Good question, though. Any more questions? Or are you just, did I talk so fast that in about 5 minutes' time you're going to suddenly catch up in your brain? And you're like, that's what you said. So when you come to the questions tonight, when you sat down at home, you're going, oh, well, just Twitter, just tweet and I'll answer. I'm more than happy to. I'm also going to hang around for a bit now. If there's no more questions. Or don't forget there's questions for the other guys as well, it's not just me.
And when you are using Twitter, please hashtag TechCluster, and then just for a bit of fun, maybe hashtag chickens and kittens.
I have a quick
See how we
question.
get on.
Joe, that was really good. Thank you very much. From as I mentioned earlier, I think some of the things that maybe EMC and VMware are doing together from a partnership standpoint, there's some pretty creative stuff going on in the marketplace. As some of these solutions evolve, any just broad comments on, we're seeing more and more about co-opetition, how people have to come and go and team in markets. Any comments on what kind of alliances you might see from this in the next 3 to 5 years that maybe aren't happening today, where people should be saying, I better be nice to this person?
Yeah, there was an article earlier this year that was run on sort of tech companies to watch. So we got the Forbes one, which was number 3 innovation in the whole world of all companies, including pharmaceuticals, everything. But this one was tech companies to watch, and we got number 1. And the tagline was fighting everyone all the time. Which is interesting because we are. If you look at it, we're competing with everyone, right? We're competing with IBM, we're competing with Cisco, you name it, we're competing with them. That's not actually what's happening. Journalists think that's what's happening, but when we get to customers, you're exactly right. It's working together on things that work for our customers. And I just have to get people to look back, like I said earlier, to when we first did virtualization. Everyone thought Intel would throw their babies out the ground. They didn't.
Right.
They came with us. So I think as we go forward, you're going to see probably more cooperation around the appliance and the hardware side of things. I think you're going to see more on the converged infrastructure space is one I'm watching very, very closely at the moment. There's a lot of players in that space bringing out converged infrastructure. It started with VCE with their huge V blocks, and now it's getting down to other companies bringing out sort of 2U, 3U units that have networking, storage, and compute in them. And I think we're going to see a rise of the white box boys in that with software from maybe ourselves and others in converged infrastructure. So in the future, you won't necessarily. I always say this to people when they talk about how to, what should we be doing in IT in 5 years' time? And my answer to that is not specifying SCSI cable lengths, that's for sure, right? Because you're certainly not going to differentiate your company from another company by specifying SCSI cable lengths better than them. What you'll be buying is pre-configured compute units that are pre-configured with a hypervisor that you just plug in and then you bring your VMs and go. You don't worry about what's inside the box. So like today, you don't care what the BIOS is on the motherboard, whereas we did maybe 15 years ago. Tomorrow, you won't care what's even inside the box. You'll just care that it runs, the hypervisor that you need and you can do on top of that what you want. And that's a really interesting area over the next few years as that comes together.
Thank you.
Yes?
Ed Crosby. In the old days, as a technical architect, effectively you're like a jockey running a horse race. You picked your horse and you rode the horse for the duration of the race in terms of building applications and stuff. Is that still the same within this infrastructure, or are there certainties?
I think so. It gives you freedom of choice of hardware, certainly, and freedom of choice of location, because you've freed it up so you can literally run it. If you suddenly decide you want to kick out hardware vendor number 1 tomorrow and replace it with hardware vendor number 2, there's actually no impact on running service levels. The same as hopefully if you wanted to move from one hosting location to another, it should be literally a case of drag and drop, but like that. At the same time, the important thing for us is making sure that people have choice above the stack as well. So that's why we support 90 different operating systems, more than Microsoft do, for example, on their own hypervisor. We support more versions of Windows. So I think it's going to give you more choice than less going forward. But when you get to that sort of architecture piece around the future application space and the PaaS space, again, you're freeing yourself up for choice, because your interface in a PaaS way is you turn up with an application and you request a service of type. So you say, I want a service of type object store. Now there would be maybe 4 object stores available in that PaaS, and you could pick one of them. But the idea being that you could have picked any one of them. You're not tied to, you have to use database of type DB2, for example, or SQL or so on. So I think going forward, you're going to see more choice at every level, which in some ways is more complexity, but it's also more freedom. It's actually relying more on what you're now seeing is the API wars. As comes out a lot in our industry of people caring about APIs, because they're the interaction planes between these individual layers of service. I think what you should be focusing more as an IT architect going forward on is delivering a differentiating service as opposed to an architecture. I think you'll care less about what it is than about what it does. If that makes sense. There was another question I think over to the left. Yeah.
wondering if you comment on the dynamic between the players, the Pivotal, the VMware and the EMC, which are together
Yeah.
presenting a technology stack.
So I think the best way to talk about that is it's actually, in my mind, very clever play by Joe Tucci, the CEO of EMC, because EMC work with the hypervisor providers with their software, with their hardware, and in fact, I'm probably more in contact with the EMEA CTOs of HDS and NetApp than I am with EMC, to be honest. At the same time, we are not particular about what storage or what processor we run on, and we're not particular about what runs on top of us. And at the same time, Cloud Foundry and the Pivotal guys will run on OpenStack, they'll run on other stacks as well, so it's giving choice at every level. Obviously there's going to be optimizations between us as a family, because we'll take advantage of that, which gives our customers benefit. What we don't want to do is lock our customers in by doing so. So it's always about keeping those interactions very, very separate. But yeah, if you look at it in this purest way, I suppose you're looking at EMC maybe as the hardware layer underneath. You're looking at us as the BIOS and the operating system being Pivotal, if you want to lay it out in a very simple way. Does that answer your question? Good. Any more?
Okay, we're good. Cian, can you just give us a quick update, please, on the awards?
Just, can I ask one other quick question for doing? Just from the StrengCom perspective, I thought I heard something about accreditation or something, and my ears always kind of peak when I hear something like that. Is there some additional value? Or I don't know if you can elaborate at all on that.
Sure, yeah. The VDC product that I was talking about there as one of our offerings, we were quite lucky today, or sorry, not lucky, we're delighted actually today that we received ISO 27001 accreditation for that product. It's something that probably I've been involved in, and another few guys in the team, to probably differentiate the product. Where we probably see certification making a difference is supplying to other customers or consumers that want to consume our cloud service who are certified in themselves. It's not a case that us being certified automatically makes the customers be certified, but it makes their certification process easier. They don't need to audit us. That our audits stand on their own and can kind of go as a pack to the potential customers. So it's something that we're delighted to have gotten the last few hours.
Okay. Yep. Thanks very much, Joe, for the interesting talk. And I'm a bit of housekeeping, so bear with me. There's a number of streams of work going on with IT at Cork. Two are SkillNets and Leaders Awards. So we've been approved and funded as a SkillNet. This means we're able to provide yourselves with training at a subsidised rate, probably 25 to 50% subsidised against market. So we're compiling training needs for yourselves as member companies for 2014, and also there's some courses selected for the end of the year. So if you want to feed your training requirements into IT Cork, if we can be of assistance in that, let Sarah know, and you've all registered today so you know how to do that. And secondly, and more excitingly, we are running Leaders Awards 2013 as a previous winner of Leaders Awards in 2010 for Best IT Department at the Healthcare. I could definitely recommend the evening. My career has gone from strength to strength on the basis of this award, and when we rebranded it, we rebranded our award and everything back last year. The show starts here. Oh, it's very good. So it's here in this building, I think downstairs. So it's going to be like a gala event, suit and cocktail dress, 7:15 on the 28th of November. Joe, you're welcome to come back if you wish. And the key here is you have to nominate yourself, and no one will nominate you. Only perhaps you might be lucky to get nominated, but you nominate yourself, right? And there are 6 categories. And the exciting 6 categories are high potential start. I don't have actually nominees here now, but high growth company, sustained excellence, research and innovation project, and yes, we still have IT department, but with Leah we call it IT team, and excellence in education. They're the 6. And it's a good event, it's a great night. I think this is our first time doing it in County Hall as well, so it could be a nice event, I think, from that perspective. So mark your diaries for the 28th of November. I'm sure tickets are available now. And oh, there was a third one. Joe is second of a 3-series Tech Talk, and the third in the Tech Talk series is Trend Micro's Bob McCardle, and his talk is probably around the first Thursday, so we're back to Thursdays again in November. So thanks very much.
So that's it really. Like we said earlier, the success of these things is down to you guys, so thanks very much for your continued support, and please, 7th of November again, Rob, he's the manager of Trend Micro's forwarding looking trend research team in Europe, so and the title of his talk is Lessons Learned from the Trenches, so sure to be another good one. So thank you all for coming, safe home, and hope to see you all soon.